Welcome. We will be talking about quickly learning how any software works today. We will be talking about what is required when you are exposed to a new code, how a developer can be helped or can use SciTools Understand to help them learn about the code they did not write. So before we start, a little introduction about myself. My name is Stéphane Reynaud, and I have been reverse engineering code, helping people with spaghetti, basically, for, almost 10 years now. I do mostly work with SciTools, so I do have an email at SciTools, SciTools.com. I'm also involved with working with customers and helping them solve problems such as documenting code, reverse engineering code, computing valuable information to do certification, or also DevOps project in terms of validation or coding standards. And that is the work that I do through emanda.com. And lastly, I have my own consulting company, 3dspider.com, in which I help people develop custom script, custom work, mostly around C and C++. So I'm an expert into coding, but even knowing a lot, what I did to address this seminar is to do a little research. So I went and I read a lot of articles about what is it about writing or reading someone else's code. And there is so many articles out there that explain, a large amount of techniques or how people address this problem. You get a code, you did not write it. How do you read it? How do you make sense of it? And I really love the last article I found, which is that most programmers can't read code. And the author is pointing out that reading code is actually harder than writing it. And I would have to say I agree with this. And we are going to cover that today. I'm going to help with some techniques that will help people be better at reading code. The challenge is that it's really harder to read code than to write it. And I love a few part of those articles I read. One said you have to pretend that you are Sherlock Holmes. And it is true, you are actually running solving a crime, solving a code by finding clues and finding things in some things that you don't know anything about. And you have to be that person. Also, and I think the most important here is that when you actually read code, the amount of data and the amount of information that you need to keep track of so that you can make sense of it is really huge. And it also, there is a lot of unknown there. When you write a code, is different, right? You are focused on the problem and you are the author, so you know what's there. But reading code, a lot of data that you need to keep track of. You also, and I think that is a question for a lot of people that I always have when they come and they say, I want to reverse engineering code. What is the end game for you? When do you think you are going to have understood that code? And, the best answer to that is that you need to build a working model, a mind map, a design of that code in your head, right? You need to build that model, and that's when you achieve understanding of it. And it's different from everyone or for everyone. So that's actually where there's a big tricky part, right? Another thing that is kind of important is that we have a quick tendency to say, this is too complex for me. And that person that write this thing is either smarter than me or it's too complex. I'm never going to achieve this goal to understand what they try to do. So I'm going to write my own instead. And that's a big loss, because what I have noticed over years doing this job is that, yes, it sounds like something you cannot solve up at front or up front. But when you get to it, there is that waha moment where then you start realizing that, hey, you've done it. You understood what that person was doing. And then it's going to help you reuse that code instead of writing, the same thing. So there is like something really important there. And basically, like, this is what it is, right? The only way to get as smart as the guys that wrote it is to actually read what they did. And we're going to give you 8 tips and tricks. I'm going to show you how Understand can help with that. And, you are going to become a super developer with superpowers. Basically, there's a funny story about that, but that was one of the marketing things we used for a trade show a few years ago, and we get in trouble for that because I think it's a bit pretentious. But here specifically, I'm going to really focus on things that you have to do when you're trying to understand code. It's going to help you, and that experience is going to be something different from everybody for everybody. So I hope you'll find things that would be meaningful to you. So what are those 8 tips and tricks that I'm going to share with you today? Well, one, we are going to look at, and this is gathered from what did people do to understand code? When you read those articles, what do people suggest you do? And the first one is, hey, guess what? Set up an environment, run your code, and see what it does. I mean, fair, simple, that is fair. This is where you actually learn about what the software does. Unfortunately, as we'll see later on, sometimes you can't even do that. The second suggestion is, go and look at the big story first. Look at the code as a whole. Try to build, what piece go where and what is what instead of focusing on the main function. And it's not easy to do from the code itself, and I'll show you how to do that. Now, where do you start? When you look at something, well, there is a good starting point. I mean, this is the main function. We all know about that. Finding it sometimes not that easy, especially if there is no main. So, looking at entry point, and then you go from those input, those entry point, and then you go and you look at, hey, what's going on? And the best way to do that sometimes is to look at the example. So you see, if you want to learn a library, do not go look at the code of the library. Look at the example, look at the test. We'll show that in a minute. Another thing is, useful thing. We will all do that when we look at code. Graping, looking for string, looking for pattern, looking for hints that tell us, hey, this is where the code is going to be doing what I'm thinking is doing. This is at that place. So how do you find this? There is also, reading classes. Simple thing, but in every languages, when you have classes, hey, how is a class structure? How does it work? What does it take? You need to understand those. And while you progress in your research, there's also something you need to do is to record your experience. I mean, you are going to, as we say, there is an overwhelming amount of information that's going to come at you. Just even go through a cold tree and then try to experience that, So you can't keep everything in your mind. You always have to kind of like keep track of what's going on. Again, at another trade show, we use one of those little Simon games there where you press and you have to repeat the sequence, and it's becoming longer and longer. And everybody fell at some point with that game. And it's the same way when you read code. You need to keep track of what's going on. And then, another technique. Sometimes you think you understand it. Well, don't be shy. Change the code a little bit. Make it so that it try things. Look at make small change and see what happened. And that's actually kind of like a technique. And there is version control to do that. Refactoring is kind of a tool you can use. I'll show you a little bit of that. And then our end goal, of course, is, retelling. So once you learn the code, being able to tell it to other people. And this is where you want to be at, right? Once you understand the code, you should be able to explain it to people. I love the expression rubber ducking for that. That will be where we finish. Rubber ducking, meaning, you have to explain to your little rubber duck toy what the code is doing. It's a great way as well to go about learning a code. So we'll visit those 8 things. And that's what we're going to do one by one. And I'm going to show you and to explain how SciTools Understand can help at every level. I'm not going to go in too much detail, but I just want to show you 8 of the basic things you are supposed to do when you're actually reading code, 8 things that are critical for you to understand the code. We are going to review that one by one. So, The first one is setting up your environment and running the code. Sadly, sometimes it's not always possible to set up the environment. You may get a code you don't compile. I mean, it's something like, let's say you download something from the web, like a GitHub repository or something. You're not going to want to spend maybe hours to try to build this thing. Well, it's great if you can, and if you can, it's the best way to do it. But if you don't, sometimes you don't have the ability to run. Also, sometimes you are not able to do a complete static code analysis of that code. Well, luckily, SciTools Understand can help with that. So let me just show you, this is SciTools Understand. And one of the things we have added recently is a lot of example projects that are actually real projects. So that's actually really cool. You can actually go in the example project here and you will see some open source project. And I'm going to use OpenCV. OpenCV being a visualization library. And this is not something we're able to compile or to run, things like that. And Understand is able to do that because with Understand, you can only analyze a single C file or a single Java file or a single thing. It will give you information about what's in it. That's actually what's brilliant. Also, you don't really need to have to compile the code because you may be missing header, you may be missing third-party library. There is ways in Understand to get result, even if those things are not defined or if you don't bring the complete project into your analysis. You may be missing things, but once you have analyzed something with Understand, you will see all the entity, everything that's defined in the project here, and you can easily click on it or double click on it to go and jump to that definition of something. But as I said, project may not be complete. In this specific thing, see, if I actually go and I look filter unresolved entity, so I'm going to hide everything that I actually have in my project, and now I can see everything that is not, if you want, things that I use in my code that is not actually in the project. So all those things are actually things that are not defined, that are not part of the project, but I know I use somewhere. So let's look at function, for instance. An atomic add fetch here. I don't have a definition for it, but I know it's in my project somewhere. It is used somewhere. So that's great, actually. You don't really have to have a project running. That's one advantage. Then you can actually deal with things missing. But, how do you run something if you don't have binary run or stuff like that? Well, you can't. But can we do something about it? Can we actually do something like, for instance, that atomic add fetch? Where is it used? Well, Understand lets you do this. So I'm going to do a little bit cleanup here. I right click and I do explore call by. So see, this is atomic add fetch here is being called by an operator plus plus. Where is that happening? It's here. So I can actually trace back, like people said, usually explore your call stack. Well, this is the call stack here, and I can go back. Map is actually calling operator plus plus. Where? Here. It's actually, you can see it's line 295. It is here. So that's just that call. And I can actually go and I can explore. And I can go all the way to data buffer. This is where, eventually we are going to go all the way to atomic add fetch. Fairly good ways to do things. And then, like running or whatever, debugging, you can actually go back in your research here. You can go back to the bottom and kind of go back to all different places I was earlier, right? So this is a way you can actually go and explore code and see what things have been, how things are called or how the things is executed through a static code analysis. So I'm going to filter by function again. This time I'm going to show the function that I have defined. I'm going to say no filter. One that I like to show is OpenCV. Hold on, it's merge from. So this one actually is interesting in OpenCV. Okay, here we go. That's, I believe, this one. So, you can actually do those call from everywhere. So for instance, I can go and I can see on this thing, I can easily do graphical view. I can do butterfly, for instance. And this is going to show me who is calling me and who am I calling. It may actually be taking a little bit of time here because the graph was complex, but see, this is like how you can also explore, where if you look at that function merge from, where is, what is the logic that actually drives you there? Or if you want to look at merge from and you want to see the logic that's in it as well when you're going to explore, you can actually also go and do things such as the control flow. And the control flow is just going to show you the logic of that function. And if you are interested to explore, one of those functions, you can actually start drilling down. Like you can have a visual aspect of, hey, this is what's going to happen when I call this function. So while you cannot really execute things, there's plenty of diagrams that's going to let you know and follow the flow of execution in the code. So you can run the code, you can explore, and you can right click on every function, and you can actually look at what's going on. The second thing we wanted to look at was, we want to look at the big frame first. You start from a code, so it's good. You can actually go and right click on function and look at things, but sometimes you need to put things in context. So how do we do this with Understand? How can we actually build a mind map of some sort of a hint about, hey, what's going on in this code? I'm going to open another of the example project. I'm going to use the Boost file system. And again, we're going to see if it actually works, this one. So see, this one works. So this one, Boost file system. So you don't know anything about that project. You don't know, but we are looking at Boost. Boost is a C++ library that has so many functions. And file system is a way you can handle and describe file object, things like changing a relative directory into an absolute directory, those type of functionality. So you don't know anything about this. And again, how do you get the big picture? Well, and Understand you can do a project overview that's going to give you actually what we are looking at, right? There's about 4,000 classes, 10,000 functions, 290,000 line of code in this project. Do we want something a little bit more precise? Yes, we can. We can use metrics for that. I can do a tree map here where I'm going to look at every file and I'm going to size those files based on their size. And I'm going to use the count of the sum of the cyclomatic complexity of all the functions in those files as a color mapping. And so if I actually do this, what you are going to see here is the big visual diagram of your code. Where is the meat? Where are things happening? This is the directory structure. So this is my Boost here, and this is my external. External in this case are all the system header I'm using. You may or may not have that in your project, but you can see this is like specifically looking at file system in Boost. Where is the stuff, right? And specifically in this project, we really see everything is in file system. This is where I have my big file and my big complex file. I do have things in the regular expression here as well, or here. There is some twist here that I'm kind of like really like flying really quickly over. But basically, like, this is a view of, hey, you know what? I'm looking at this project. This is where the interesting thing is in the file system, right? So this is one way to actually see where interesting things are. Another thing we can do here is the dependency graph. And I like that one. It's another by directory structure. This is what you'll have by default. So basically here, what I'm going to create is, again, the same idea of how things relate to each other. And as I told you earlier, external here is the system header and Boost. And basically Boost is dependent 10,000 times on the system header, but I'm really interested into just seeing Boost and what's going on in Boost. And Boost is library, it's a set of library. Those are the library. And I can say, hey, show me what's going on in the library here. So it's show edge between children. So here I'm going to have a graphic representation on how all those libraries kind of relate on top of each other. How do they relate to each other? And really, like, you can see what's on the left here. Actually, it might be the opposite, but you can actually start seeing how things go and are relate to each other. One of the trick I do is that all those relationships here show you any type of relationship, call, include, things like that. But I like to do, when I first look at a project, I like to just use the include here. So I'm just going to filter out every other type of relationship and just keep the include. And you will see the graph is going to become a lot simpler. Up, and then I'm going to regenerate this. So see now, like we are having like actually a flow of things, right? File system, and you can actually see we go from file system to config, and we can see how the include is actually building your project. So you can see what file system is directly dependent on. If you really want to see that, you can even highlight it here. And then you can see, okay, so it's really dependent on those things. And this is a great way to really like, as a big picture, to get started into a project, right? The next thing we talked about was how do I actually go about finding starting point, beginning of use case or example. How do I actually go about finding where does the code start? So and as I said, I suggested to use the example for this. And so let's actually look at another project, which is RDuPlane. And again, I'm going to use the RDuPlane 409 here. So it's another example project. And Understand lets you actually easily find the entry point in the code. So in these specific things, I may be looking for the main, where to start? Well, guess what? We have the main function here. And would have not been super obvious as you realize the main here is in a macro, is defined in a macro, but I have identified all the main, so I can actually go and do that. The same way, there is all the root call I can do. And this actually is interesting because you will find a main in it, but you are also finding all the function, every single function I was defined in the code that are actually not called by anyone. So this is a great way to, if you are looking at a library, hey, what are the things that nobody's calling or not called? So it's either dead code or it's actually your entry point into your project. And we do have the same thing for classes and also for includes. Anything that's not included by anyone is probably going to be your basic, your external API. So there's plenty of ways to find that. Let me actually go back to the Boost project to show you something. Because the Boost project, this analysis, actually, I'm the one who did it. And what's interesting about it is that it's actually based on the example, meaning we just analyzed the file system and then we just brought slowly everything in that was used by file system. So if I actually go into file system, an analysis of the example here, and the example that's kind of interesting is we can look at path info, for instance. So you have a main here, right? And when you are looking at code like that and you start from a main and you're going to explore that code, well, we could actually just really do a graphical view and the control flows I've shown you before, right? And we can start drilling down. But sometimes you are just interested, what does this main, what this path info example is actually using, right? So one way I do it is I usually take the path info here and I do a graphical view and I do the include. Basically, it's going to show me, I'm going to switch the level to 1 level at first, but hey, path info is going to use stuff, and the way you use stuff is by actually including files, right? Then this is what is including, and I can even actually go and says 2 level now, and I can actually start seeing what path info is dependent on, right? And sometimes it's a little bit confusing, but if you use there is multiple variation of every graph in Understand. If I go into a cluster here, and I aggregate it by the directory structure, I can actually start seeing as well, I see the file that I'm included, but I'm also seeing where are those located? So obviously this is a system file, right? And this is just basically boost, and it is in the file system library. Guess what? If I go at level, I do 3 level. Now I'm going to start seeing things a little bit more interested where, I'm going to go in boost in file system, but then I'm going to go to smart pointer, type traits, IO. So I can actually see more than just a simple list of files. It's actually fairly brilliant. And you can actually do the same thing with the call. If I go back to that main function and I do a graphical view and I do a call, and I do the cluster, again, don't forget the cluster because you can aggregate things by different things, and I aggregate by directory structure again here. Now I'm going to get a call tree, but all the function will be aggregated by the location or the files they are in. And so here you go. So see, I can actually start seeing how main is calling things and where are those things implemented and what they relate to. So obviously operation.hpp, that's really the big file I'm using. I'm getting a lot of information here. So just to sum up, really easy to find the main, really easy to find the function that are the root of things, and really easy when you have found those to go and to keep going and explore what's happening. Greping, finding stuff. I mean, so many people I talk to, I said like, hey, you're looking at code. You are just basically going and greping things and searching. And, you have a button that has a specific text on it. How do you find where that text is? Well, this one is fairly quick to address and understand because there is like a tool here, which is a quick search, which just basically going to help you do anything. And in terms of searching things is brilliant. So, you could actually say error because you're looking for error thing, but you are going to get so many stuff. You get error in a comment, you get error in things, and you may be looking for something that is really specific, a string that is used somewhere. And yes, sometimes it doesn't work because, strings are in a resource file or something like that, but you can always try it. You can type string here and error. Now I'm going to find all the places in Understand where there is a string that has error in it. So I don't know, like, fail, maybe I could do fail 2, right? Maybe that's the text you're looking for. So I'm finding all the place in the code where there is something that says fail 2. And that's a brilliant tool in order to find entry point, debug point, research in your research. Similarly, like, you may be doing something with a password, for instance. Is there anything, I don't actually know on that one. Does this one? No, there is no password. But if you are looking for things, you can actually go and look at string. But there is another one that I love, which is identifier here. And let's go back to error. I'm going to find a place where there is any sort of places where there is a variable or an identifier that contain error. So I'm going to go, it's not going to show you the place where there's error in a string, but like if a variable is named error. I use that for PWD, password. A lot of people that I work with in the security field, they use that really useful in order to find things. So, money maybe, do we deal with money? No. So, but you can actually go and specify your search. There's a little help button here, and it's going to explain all this. You can do search string, identifier, comment, test. There's plenty of ways to search things. Greping at that point become immediate. The speed is immediate because it's pre-parsed. And so CC is going to make your life a lot easier when you're actually exploring some code. Reading classes, we talked about function trees and stuff like that, right? And a lot of people sometimes when they come, they say, I have classes, I need to look at classes, a lot of classes, help me create UML diagram. Well, I will have a seminar in the next few weeks about UML diagram specifically, but I think there is a lot better than UML diagram for reading classes or exploring classes. And let me show you that. For instance, this is our boost file system, right? So if you do the project overview here, there is 3,748 classes. So someone that comes and says, well, can you make a UML class diagram of all the class? unless you really want to create something and print out something so that you could decorate your living room with it, I don't really think that diagram is going to be helpful, especially on a big project like that. But you can do it. And you could actually go, I could actually go here, graph, and say project graph, or like UML class diagram here, and I could do by directory structure. That would exactly create that diagram. I'm not going to do it because it's going to take forever. It will work at the end, but I don't want to do that. I want to focus something a little bit more smaller. So I can actually just click my file system here, and then I can do a graphical view, and I can do the UML class diagram on this, right? So before you scream, yeah, it doesn't look like a UML class diagram, but that's kind of the concept. And again, if you want to do UML class diagram, wait until the next seminar. So let's focus on the boost file system path. Actually, that's a good one because it's one that shows a lot of things. And again, what can we do for a class in Understand? Well, if you right click and you will see there is a lot of graphical views here. I do like the call and call by. So basically, what these actually show you is all the functions that are going to call some member or something in your class. So you can actually see all the functions that are calling you and all the function that you are going to call somewhat. And, like for instance, path internally, that class is actually calling that dispatch, that specific version of dispatch 8 times. Why do we have so many dispatch? See if I go in this, there is a lot of dispatch. See bool file system dispatch here. I could actually see them if I do file name, show parameter as full parameter. So see they are all dispatch with different parameter type, right? So that's why we have 8 of them here. But this is all the function that you call and that you call. Great way to look at, hey, who's calling my class, what's happening to it. What I love, again, don't forget there is variant in your thing. And then I can do the internal one. And the internal one I do like because this is this one is kind of showing you how the class is structured. This is all the function in the class, and then you can see who is calling which. So at that point, you are able to really see somewhat of, how that class is built and what are the things that are more like an underlying things versus like something that's kind of prime time and being an external interface. So you can really see how that single class is structured. It's quite useful when you are trying to understand a class. It's only showing the function and showing the call, but if you were interested to see that with the variable and all the stuff, I would create what's called an architecture. So I can design a browse architecture here. It's going to create an architecture. In that architecture, I can, call it like, let's say Stefan, right? And then in Stefan, I'm going to move this class, and I'm also going to move this class because it's defined. So now, if I take on that thing and I do dependencies, right? And then I'm going to actually see that path and path constant, and I can see how there is a level of dependencies. Remember the big graph we created at the beginning? Well, we're able to do that, but just locally on what we're interested in. So I can open those. And by default, it doesn't show the dependencies within an element. So again, when you do graph, and that's for performance reason, we do that. You do show edge between things. And let me just get rid of this. And now this is actually the dependencies, including everything, object, function, all those things. And for instance, I'm going to filter this graph. I'm going to say, maybe I'm just interested at looking at the member object and how they are used by the function. So I really don't care about those. What I really care is about using, set, and modify, right? Because that's what I will do to a member object. So here you go. The graph is redefined. I'm going to go back here, and I'm going to show the edge between here. So now we can see, well, guess what? All those member function are actually calling that member object and path name. So that's basically like, it seems like this is my big main piece or my big meat in my thing. And there's value type, reverse operator, right? Which are also objects. So you can actually start seeing, how understanding a little bit more about the class and its intricacies. So a lot more than a simple UML diagram with what you can do. Okay, record your reading experience. Well, we have done a lot of things today, and sometimes you will want to go back to what you have done. And again, we can do this by simply using the back button in Understand. I can go back to every single place I was before. But Understand will let you do a lot of things. It will let you create little bookmark like this. So see, I'm printing those things. I can make mark and then I can re-see them by having them. So I have all my bookmarks that are at my different places. There is a way to catalog this. Sometime you are interested to say, this is a macro I'm really investigating. Well, guess what? You can add things to favorite. So you can create a list like that of favorite, like this macro boost test I actually just did this. So when you're exploring, and you can have as many favorite as you want, and those are saved with the file. So, tomorrow you work on one problem, the day after you work on another one. Well, guess what? You can have different type of favorite, one per day. And, you come back to your desk, you want to see what you had before, where you can just, in one click, you can reopen the definition of all those favorite. Great way to start and keep track of your work. And also, we do have annotation. So that means that you also can write your own mark on objects. So again, boost test, I try, maybe that's the one you want to keep something, make a note in this, but you don't want to add a comment. You can annotate things. So I can annotate this guy, and I have an annotation viewer here. I can, this is the one. So I can actually save that. And then I'm going to actually say this is the one, and I'm going to put it an acronym that will be problem A, right? So I have my note, and again, those annotation, you will be able to research them later by browsing them, and even you can search them, right? So I could, of course, there's only one here, which is problem A, but if I had created a problem B, actually, why don't I do that? So C is not showing up here, but if I do that, then I see both annotation. So great way, and then in the code you have your little annotation. So the tool lets you explore code, lets you create annotation, let you keep track of what you've done, where you were, things like that. And in terms of navigation, when you're going to go and exploring code, this is a pretty brilliant tool. Refactoring, use version control and make small change. I mean, those are like the things. Sometimes you look at the code and you are curious. You may want to make some small change. We let you do that. Understand is an editor. You can, you have the ability, if you do change a file simply, you can do an analyze change files. So even if your project took like 30 minutes to analyze originally, you may be able to get a new analysis in a few seconds just by analyzing the files that have changed. This is great. If you want to, sometimes something may not be meaningful. For instance, that template, I don't know if that's going to work, but we'll try. I can go and I can do a refactor on it. So you can actually go and rename things. So I'm going to rename that E2, for instance, and Understand would actually show you all the places where refactoring or changing that name will apply. So another great way to, sometimes you have function, let's say you get a code where we have a marketing thing that says, he has named all the variable out of his favorite alien name. Well, guess what? You hit a code like that where someone used planet names to name variable instead of meaningful things. You can easily yourself replace them. You can easily change them, reanalyze, and get something a little bit more meaningful. We have ways to refactor function, things like that, but I'm not going to get much into this. The one thing that I should bring up is that if a project is actually a Git project, and I do have one here, hold on, it's reshade me here. So this is like a project, actually that's a Git directory in this one. We also are going to help you whenever you look at the code here, you are going to be able to see the history of that code. So course, I picked the wrong file that doesn't have much, but it's just so you can actually go back in time and you can actually see, all the changes that were made to that file depending on the commit. So we do have a visualization. I know it's nothing fancy, it's nothing new or original, but at least you're able to see and to visualize change without having to go and access a specific Git tool. So I can actually go and check, where the change were made, and then. So something interesting, there is a history there. There is a big thing which I am not going to cover today, which is the ability to compare project. Again, that's going to be in a later seminar. But we do have the ability to help you with minimum refactoring, minimum understanding of what has happened in the past, especially if you're on a Git project, and also the ability to analyze those projects fairly quick. If I just go and say like, see, I save this file, I do project analyze change file, well, it's just going to just basically analyze into like 2 seconds, right? All right, so, and eventually that leads me to really my last slide, which is the rubber ducking function, the retelling. And the question is for you to think of, right? Nobody wants to write documentation. It's a core, we always hate it. But then we are always mad when someone doesn't have a documentation with this code and we'll call him names, right? But so documentation is painful, but adopting Understand and being able to create those diagrams, because every single one of them can be saved, can be printed. All those logic and all those tools that I've shown you, those tips and tricks, you can actually use them. And when you are actually like really familiar with them, explaining a code to someone is really, really easy because you have all that structure, all those visualization available in an interactive way. So you can even interact with that person. They ask you question, you'll be able to answer. So you can become that person. And guess what? If a person that you inherited the code was able to do the same to you, which is show you things and understand, I think it would have made your life a lot easier. So it's definitely not, a selfish behavior to go and try to do a better job with Understand here. And there's no lie. I mean, like, I can try to convince you here, but this tool success is based on the fact that people read code with it. So I think you really want to give it a look, especially if you are basically in a research for something to help you understand code. And again, this is just a basic of the tool. This is just some tips and tricks that I came across that I like. Let the machine help you was one of the suggestions from the article I read. And I think this is like, let SciTools Understand help you. Just a few action items for, what's to do next. Well, one, I would suggest that you try to find, so it's not, if you are live on the seminar, you'll be able to register for them. Otherwise, if you have seen this as a video, you will be able to find the video of those. But I'm going to cover other features that I'm not covered today. The first one is, we talked about UML diagram. Software design documentation is a perfect place where you need this. So I'm going to talk specifically about creating documentation with Understand. We are going to cover that in the next session. I'm also going to have another session where we are going to go in more detail about refactoring. Basically, you have a code that you have understood based on some of the principles we have explained here. How are you going to make sure that nobody screw it up later, right? How do you make sure that if you touch something, you're not going to break something else? And the perfect analogy for that we found is, it's like you come, they ask you to renovate the house. How do you make sure you don't break any bearing wall and make the whole thing crumble, right? Because now that's an expensive proposition. And then there is a last seminar that I'll invite you to, and that one is really a game changer, which is the next generation QA with historical DevOps. So you saw a little hint here where I was able to go back in time in the system. So Understand as a time dimension. And exploring that time dimension with the structural analysis of the code is creating a new opportunity here for a whole brand new type of QA work where you're not going to waste time on things that don't really need to be tested. So more soon, we'll talk about that. I mean, those 3 seminars I really recommend, as a software engineer, you look at them, you try to come to them. SciTools.com/events, you can register there. And lastly, you want to evaluate, understand, go to the SciTools.com website. There is a free trial. You just have to register there. Please make sure to use, your work email. We don't spam you, but we like to get your feedback on the tool. We like to help if it's possible. And if you're really not sure, if you have questions, if you need, this seminar gave you ideas and you want to validate things, or simply if you want me to help you with your spaghetti. 3 ways to keep in touch: SciTools, Amanda, or 3D Spider. SciTools.com, any general question about the tool. Amanda, if you want to buy it. 3D Spider, if you want me to do some consulting for you. So anyway, I really hope you have enjoyed this seminar. It's a good introduction. I did not go much in details in things, but please try the tool. I mean, it's going to make your life easier. And thank you very much for your time.